Okay, so we're going to look at congruent and similar triangles. So first of all, congruent. So congruent triangles are two triangles that are identical to each other. So they're two triangles that have the same angles kind of compared to each other, the same sides, the same everything, okay, identical to each other. And we have four different ways to prove that they're congruent. The first way is all three sides are equal. So that's your side, side, side. The second way is two sides and the angle between them. So that's my side, angle, side. Third way, two angles and the side between them, so angle, side, angle. And the last way then is right angle, hypotenuse, side. So if both of them have right angles, hypotenuse, and then one side is equal on both triangles. And when we're proving that triangles are congruent, the main thing to do is kind of to work your way through proving different sides, different angles equal, writing down what each kind of point represents. So if you prove a side is equal, write down that it is a side. If you prove an angle, write down that it is an angle. And then once you've kind of fallen into one of these rules, so whether it's all the sides, a side, an angle between it, and another side, or whatever it is, then you write that down at the end, kind of listing that out as your reason as to why they're congruent. So looking at that in practice, we'll give a go to this example here. So we're told AC is equal to AD and BD is equal to CE. So looking at BD here, BD is this point here and CE is this one here. And if we just take this to the side here, BD being equal to CE, I can split BD up into BC plus CD. And I can split CE up into CD plus DE. And if those two things are equal, that must mean then that BC would be equal to DE. Okay, so that's going to be important for us. So if I now take my triangles that I'm looking to prove, so take my triangles out to the side here, so this can be ABC, and we'll maybe make this ADE. First of all, I know that these are equal because I've been told. The second two sides that I know are equal are these two ones here, and that's from this point up here. So maybe we'll write those both down. So AD is equal to AC, and that is a side obviously, and that's given. Okay, BC being equal to DE, and that comes from up here, and that again is another side. So what we might like to do here is find the last side, but there's nothing really in the question that we can specifically use to give us that last side definitely being equal. We possibly could kind of work our way around it. But one other point we can look at is that this angle here and this angle here will be equal to each other. Okay, so angle C would be equal to angle D, and that's because it's an isosceles triangle. Okay, isosceles. How am I spelling isosceles? Isosceles triangle. Okay, what that means then is angle ACB is equal to angle ADE. Okay, so what I'm saying is that this angle and this angle must also be equal. And the reason for that is that those two angles, that kind of pair of angles here, would have to add up to give me 180 degrees. And the same thing is true on the other side. So that actually gives me an angle. So what I have now is I have a side, I have the angle between it, and I have another side. So I can say then that ABC is congruent to ADE, with my reason being side, angle, side. So we can see here, you don't necessarily have to work out the points in order, but you have to make sure that when you're using your rule that it falls under the rule in the order that it has to. So it can't be two sides in any angle, it has to be two sides and the angle between those two sides. So let's look at that then in terms of another example here using a parallelogram. So the first part asks us to show that ABD, this one here, is equal to BCD, which is this one here. And for this here, we're using really a lot of our parallelogram rules. So we can say that AB is equal to CD. We can say that AD is equal to BC, and both of those are opposite sides of a parallelogram. And we should know that opposite sides of a parallelogram are equal. Okay, so they're both sides. And lastly, where BD is obviously equal to BD, and that is a common side. That's common to both of them, and that's another side. So therefore, they're congruent And our reasoning, our rule that we've used is side, side, side. All the sides are the same, so they have to be congruent, they have to be the same. Looking at part 2 then, we want to show this time that this smaller triangle ABX is equal to CYD, this one here. And we have a few different ways to go with this one. Okay, so first of all, we could say that AB is equal to CD. Okay, and again, that's from before. So they're opposite sides of my parallelogram. So that's going to give me a side. That's going to give me one side anyway. Now, what I might like to do here is work out some of the other sides, but there's nothing really again in the question that's kind of given me a quick way to find out one of the other sides. Something that I do know is that in a parallelogram, opposite sides are parallel to each other. And when I have parallel sides, I can use my parallel rules. So for example, I could draw my Z shape here to show that this angle at B, let me use maybe a different color there that'll be a bit clearer. This angle at B here would be the same as this angle here down at S. I might get rid of that pink even just because we've seen it now. So we're saying that this angle here would be the same as this angle because of alternate angles. So drawing in that Z shape there so we can see it kind of a bit clearer. So we're saying that angle B is equal to angle, sorry, I'll give it its full, we'll give it the full name. So the size of ABX is equal to the size of CDY, and that is by alternate angles. And you can see there I'm kind of naming them in terms of the triangle that they're in. So that's going to give me an angle here. So if I have a side and if I have an angle, I might like to either get the other side, so I can do side, angle, side, or the other angle, so I can do angle, side, angle. And what we know is both triangles have a right angle as well. So if they have a right angle and if they have another angle, that's going to imply for me that the other angle, BAX, would be equal to my other angle on the other triangle, which is going to, we'll say, we'll call it YCA. Okay, so, and we can say angles in triangle add up to 180. So if they have to add up to 180, that last angle has to be the same. And that's another angle for me. So that's this angle here, and it's this angle here. So that means that they are congruent, with my reason being angle, side, angle. So two angles and the side between those two angles. Now what's interesting about that one is we see the right angle and we might think, oh, I'll use my right angle hypotenuse side. And we could work out the right angle and we could get the hypotenuse, but getting that last side would be the hard part there. And sometimes you'll start to prove it thinking you're going to go with one rule and you'll end up having to pivot and maybe use another rule. And that's okay. That's perfectly fine. And it's just, I suppose, being able to recognize when maybe you're not going to be able to prove one of the sides is the same, and kind of recognizing what is that point where, you know, you're not able to use that rule. And even here we saw then as well with parallelogram, we know the sides are parallel, but it's using then our alternate angles with that, bringing that into the question. Looking then at exam question. So again, with a parallelogram, we're told one of the angles is 115 degrees. We have to write down the angle of alpha and beta. So that kind of A and B, they're Greek letters. So we'll say, first of all, alpha is 115, and that's because their opposite angles of a parallelogram are equal. Okay, so that's going to be 115. Then we have 115 plus 115 plus beta, because this one will be the same. They should add up to a total of 360 degrees because the four angles in our quadrilaterals add up to 360 degrees. So think of your square with each being 90, or your rectangle with each being 90. So they should add up to 360. So we have then 230 plus 2 beta equals 360. 2 beta is 130, which means beta is 65 degrees. Okay, so our beta then is 65 degrees altogether. Now we need to explain why the triangle PQR, so let's draw in that triangle, so that is this, this, and down here, is congruent to the triangle ORSP. And again, this is one that we kind of saw in the last part. We saw this in the example that we were looking at. But if we were to write it out again, or P is common, so that's the middle one, so that's a side, that's this one here, it's common to both triangles. We can say then that S or is equal to PQ, and that is because they're opposite sides. Okay, and then similarly, PS is equal to or Q, again because they're opposite sides. And so they are congruent because they are side, 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 because all the sides are equal. So they're congruent because all the sides are equal to each other. Okay, we're going to look now at triangles that aren't congruent, aren't identical, but they are similar. So we call them similar triangles. And if two triangles are similar, then we say that their sides are proportional in order. And we saw this a little bit with what I just wrote past there when we looked at the parallel lines cutting the triangles. So for a similar triangle, what we say is that the side, say PQ here, is proportional to the side on the other triangle that would kind of line up with that one, which would be ED or DE there. And we write them like this here. We take the side from one triangle and put it over the side from the other triangle. And we can do the same thing with the other side. So POR and DF, we can line that up here. And we do the same thing then with QOR and EF. We can line them up here. And we can use this then to find the value of a missing side. And I suppose looking at what makes a triangle similar as opposed to say congruent, a similar triangle will have all the same angles. So the angles will all be the same, but what will happen maybe is that one of the triangles will look like it's just been kind of enlarged, I suppose, just bigger, or it's shrunken down, or it's smaller. So we can see these two triangles here, they do look the same shape, and all the angles are the same. I've marked them all in as being equal, but one of them is just bigger than the other one. But we say that it's just as if it's been enlarged, so all the sides are still in the same kind of ratio, but just bigger. And with similar triangles, it's important as well that we kind of see that we can have cases where one triangle inside another triangle would be similar. So these two triangles here that we have, this small one and then the bigger outside one, those are similar to each other. And we can see where the angles are equal, so our corresponding angles that we have kind of making the different angles equal to each other. And this kind of, again, comes back to this rule we used earlier as to why the parallel line cuts the triangle sides into the same ratio on either side. It kind of follows the same idea, comes from the same kind of rule, and we set it up in the same kind of way. But let's look at an example of how we kind of use this in practice. So we want to find the value of x here. So what we need to do first is match up the sides. And we can do this by kind of looking at the angles. So looking at this first side, the side where x is, we can see that that side is between this first angle which has the line through it and the angle that has the dot. And matching that up on the other triangle, it's actually this side here. So we have to be careful that we don't accidentally line them up with the wrong side. So what we actually have is, if I set up my first fraction, putting the angle from one triangle, what I'll do is I'll give each of my triangles a color. So we'll call this red and we'll call this green. So if I pick x from this one and we'll match it up with the green one from the other side, which is 12.6. And we just need to pick another side that we think we can match up. So let's pick on this triangle, the one between the angle with 1 and the angle with 2 lines, and that matches up with the 16.1 here. So we get that 7 is equal to 16.1. And once I have those lined up, I can use my calculator to simply kind of work out the value of, say, the left-hand side there, and then multiply across by that 12.6. So I get 10 over 23 multiplied by the 12.6, and that's going to give me a value of, I copied those down correctly, 12.6, 16.1. Yeah, so we're going to get a value of 5.49. Okay, 5.49, or we could leave it as a decimal either, and that would be perfectly fine. Okay, so the key thing there, I suppose, is just lining up each of the sides correctly, first of all, and then kind of following it out that way then. So we make sure that we've definitely lined up each side with the correct kind of side on the other triangle, and then that makes us better able then to answer out the question fully And we'll look at maybe just another example of that here. So looking at this triangle, we can see two of the angles are the same on each triangle, and that means then that the last angle will also have to be the same because they have to add up to 180. To find out the side x, we're going to match it up with the line with the side on the other triangle, which would be the 5. Do the same thing with the 6. So the 6 corresponds with the 4. And same thing again, so that's 3 over 2 multiplied by the 5. And I get that x is 7.5. And let me just double check that there. Yeah, 15 over 2 or 7.5. So the same idea. So the key thing here is making sure that you can line them up properly at the start. So write the side on one triangle over the side on the other triangle and put it equal to, again, picking another side and matching those up correctly then. So let's just look at an exam question then that uses that. So we're told to prove that XYZ, which is the big triangle here, and WYZ, which is this smaller triangle, are equiangular. So equiangular means have the same angles. So let's first of all draw out these two triangles, and what we're going to do is we're going to try and match up. We're going to draw them out in a way that we can easier match up the different sides and the different angles of the triangle. So I'm taking that right angle, which is at W, and I'm going to put that up here this time, and we'll put Y here, and we'll put Z here. So YZ is 16, WZ is A, then XZ here, so the whole way along would be 4A, because this is 3A and this is 1A, so this is 4A, and YZ is common to both, and that's the 16. Okay, so that's common to both of my triangles. So we want to prove here that they have all the same angles. Okay, we want to prove that they have all the same angles. And the key way to do this, I suppose, first of all, we can see that we definitely have a right angle that's the same in both of them. So we know that we definitely have one angle the same. All we need to do is prove that one of the other angles is going to be the same. And if we look at the triangle that we have, we can see that the angle XZY is going to be equal to my angle that I have here, WZY. So I'm talking about this angle here in the corner. So it's the full angle, even though it's different on both triangles, and it's actually just the same angle both times. So we know that that's going to be equal because it's the same angle. It's a shared angle between the two triangles. So then we can also say that they both have a right angle. So that's XYZ is equal to YWZ, which is equal to 90 degrees. And that proves then that all angles that the triangles are equiangular, because if two of the angles are the same, then the last one also has to be the same because they have to add up to 180 degrees. So answering the second part then, well, if they're equiangular, that means that they are similar. Okay, do you remember that was just another word for similar? It's another kind of way of us saying that they're similar, because similar means that they have the same angles. So again, matching up the sides as best we can. So we saw where that right angle is. We want to just make sure that, I suppose, all the other sides are matched up correctly, so we can fill in one of the angles that we have. So that would be this angle here, and that corresponds with this angle here. So we can see that we have them matched up nicely. So we have then that 4A over 16 is equal to, let's see, 4A over 16 is equal to 16 over A. Okay, so again, making sure just that we have this matched up correctly. So yeah, the 4A matching up with the 16 there, and then the A matching up with the 16 again. So we're going to do some cross multiplication here. So 4A squared is equal to 16 by 16. 16 squared, 256. We can then bring this across. Put this here. Okay, looking at this one here, we should recognize this as a difference of two squares. Okay, so I can rewrite this as 2A all squared, and I can rewrite this as 16 all squared equals 0. So I have 2A minus 16 2a plus 16 equal to 0. So 2a is equal to 16, which means a is equal to 8, or 2a is minus 16, which would mean that a is minus 8. But a cannot be minus 8 because a is the length of a side. So a side, we can't have a negative length for a side. So that means that a must be 8 and 8 centimeters. Making sure that we include our units there to get ourselves full marks. So a must be 8 centimeters. So the key things here, I suppose the key takeaways, if we start with the similar triangles, is first of all making sure you're happy with recognizing similar triangles. So they're triangles where all the angles are the same. You must be happy with matching up the different sides. So we kind of use the angles to do that, to make sure that we're matching up the correct sides with each other. And then that you're able to write those as your fractions. So writing the side on one triangle over the side on the other triangle. And you can pick which of them to write on the top. Generally, I would put the one that we're looking for on the top because it's just a bit easier to work with. Then in terms of our congruent triangles, we have our 4 rules: side, 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 angle, and right angle, hypotenuse, side. And you need to be confident with using all of those 4 rules and using them like we've done in those examples to prove that 2 triangles are congruent or identical to each other. So that's kind of 2 specific types of triangle questions or triangle problems that you need to be kind of happy with answering.